Okay, so here we go. We have the 9.3 lesson that we have to do, and this is on properties of logs. So some of this might come back to you pretty quick from last year. Some of it might feel like you've never heard it or seen it before in the past. So the two things that we have to know very well is the change of base formula and our three properties of logarithms. And so for the change of base formula, what we're looking at is if we have a base here, base A of x, we can rewrite that as a quotient of logs. And so we can say that's the same as log x divided by log A. So the x goes into the numerator and then the a goes into the denominator. So our base here becomes our denominator and then our value becomes our numerator. And so this would be a base 10, and so that's our common log, right? So if there's no subscript, that implies a base 10. And that's the same formula if we say, okay, well, what if we use a base e? So if it's base e, so instead of log x, that would just be natural log of x. Instead of log a, natural log of a. And you really can use any base. So when we talk about a change of base, so if this is a base a, we can turn it into a base 10, a base e, or any base that we want to use. And all we're doing is we're splitting up what our values are. And so that's just, one of the formulas we need to know. And then as far as our properties of logarithms, so we have three different ones. We have to know the product, the quotient, and the power property. And we really, really need to have these memorized. And one of the things that you need to think about is what are your rules of exponents? Like when you're adding, when we're multiplying, we add our powers. When we're dividing, we subtract our powers. So we need to know all of those properties. Just like we do for exponents, we need to know them for logarithms. So here, if we have a product of values, so if we're multiplying u times v, and they have in here a base of a. So then what I'm looking at is I want to assign a log to each of these values here. So I want log of u, and I also want to have a log of v. And how I can do that is by separating that through addition. So if I assign the logarithm to the u, and I also assign it to the v, I can do that so they can each get their own logarithm as long as I split it by addition. And it really doesn't matter if I have it in a log of any base, including a base e. And so this is just using the other base here. So this is just log base e, but I'm using natural log. So regardless of what base I have, the property still holds true. I can assign a log to any of those values, and then I separate it through addition. And then we had our quotient property, which is similar, that when I'm dividing, I always subtract my exponents, and a log is an exponent. And so here again, I'm assigning a log to the value of u and also to the value of v. And when I do that, I separate through subtraction. And again, it doesn't matter if it's a log or a natural log, they still get separated by subtraction. And then lastly is our power property. And for that one here, so if I have an exponent, I can take that exponent and move it down to the front and make it a multiply value or a coefficient to log. And that is, we know if we have a power to a power on exponents, I multiply those together. So log is an exponent, I multiply it by an exponent. So we have to know these both directions. So just because we're talking about pulling it apart and assigning it to the own log, we need to know the other direction. So meaning if I see that I'm adding logarithms, I can make that one log as a product of value. If I'm subtracting two different logarithms, I can make that a quotient of one log. And if I have a coefficient, I can make that a power. Okay, so that's really what a lot of this unit is about, or this lesson. All right, so let's go ahead and take a look at the first example. So for this one here, we want to rewrite the log as a ratio of first a common log. So let's go ahead and do that. So remember, a common log just means we want to use base 10. And so in order to do that, so a ratio, meaning we want to write it as a fraction, so what they're asking you to do is use the change of base formula. And so we're writing it as a common log, so we're going to rewrite it as this ratio. So when I look at this, I have a log of x, and it's a common log, so it's going to be base 10 implied. And then in the denominator, the base is my denominator. So then divided by log 3. And so then that's for A. Okay, so for part A, or the first part of example 1, that's a common log, so implied base 10. And then for B, they want it to be as a natural log, so we're going to do the same thing. So natural log, so I'm going to take the same problem, log base 3 of x, and we write it as a ratio. So again, a ratio is just a fraction. But instead of log x, so instead of doing the common log, we're going to do the natural log. So base c, so it'll look like that. So it'll be the natural log of x divided by the natural log of 3. So remembering, my base, my subscript, my base becomes my bottom. Okay? All right, so then for example 2, it says evaluate your log using the change of base formula. So now one thing you have to be careful here is I'm not looking just for a number answer, and I know a lot of our calculators can just give me that answer, but the directions don't say, hey, what's the answer? The directions say, use the change of base formula. So that means I can either use a log or a natural log. It doesn't really matter which one I choose to do. I usually use a natural log just because it's one less letter to write. So instead of log 4, I'm just going to do natural log of 4, and as a ratio, natural log of 7. So there's my change of base formula. So basically I just did example 1 again. So I used my change of base formula, and then now I'm going to work that out in my calculator. So I'm going to figure that out to 3 decimals. And so here's my calculator. So I have a natural log button, so that's for me right here. So everybody else's might be somewhere different. So I'm just going to do, turn on, the natural log of 4. So natural log of 4. Make sure you close your parentheses, so there's my top, and then divided by, and then the natural log of 7. You can also use your fraction key, it doesn't matter. And then hit equals. So it says to 3 decimal places, so for me it'll be 0 point and then 712, and that would be to the nearest thousandth. Okay, and then I know again some of us have calculators that can do that straight away, and so we can always check it for those of us who have that, the button that kind of looks like this one right here. So if we want to check it, I would just do that and then type it in. So 7 and 4. And then I got 0.712 again. So looks good. Okay, so for this one right here, we want to use our properties of logs to fully expand the expression. And so the properties of logs are same thing, you know, if I'm multiplying, I want to convert to addition. If I'm dividing into subtraction, and any power I have would become a coefficient. So just as a little reminder on this example here is if we have a square root of something that's equal to x to the 1/2, just so that we remember that, just to help us out. And then if we have a fraction, I can deal with negative exponents. If I have 1 over x, that would be the same as x to the -1. So just some little reminders here about powers. Okay, so the first thing I want to do is I want to get the square root, because it is an exponent even though it's a square root symbol. So the square root is an exponent of 1/2. So I want to pull that out. So I'm starting from the outside and I'm working in. We always want to make sure we do that. Start from the outside and then work your way in. So my outside being the square root, so I'm going to move that down to the front. So the square root is a 1/2 power. So I'm not moving the symbol, I'm moving the exponent. And then that's going to be of the natural log of x squared over y to the third. So we always want to do one at a time. And we want to make sure that we start from the outside and work our way in. So now I'm going to assign a natural log to each of these values. So x squared will get its own natural log, and so will y to the third. So then I'm going to keep working to the right here. So 1/2, and I'm going to use brackets because the 1/2 will apply to everything. And so then that would be the natural log of x squared, and then the natural log of y to the third. So all I did was assign the natural log to x squared and y to the third, and then I need to figure out, well, what's my symbol going to be here to separate them? Do I add, do I subtract, do I multiply, or do I divide? So a division is subtraction, so that means I'm going to do subtraction. And then I look to say, okay, well, can I do anything else? Is there a power I can pull down? Is there any more multiplying to switch to addition? You know, what else could I do? So if I look, I have another coefficient, or excuse me, another exponent that I can turn into a coefficient. And now it only goes directly in front of the natural log, like not all the way out to the 1/2. And then the same thing for the 3, only straight in front of that natural log it's with. So I'll have 1/2, and then that will become a 2 times the natural log of x minus 3 times the natural log of y. And then from here, so I'm fully expanded, but I could do a little bit of simplifying by distributing the 1/2, and so I'm going to go ahead and do that. And so with that 1/2, it multiplies to the coefficient. I don't want to multiply it to both of those, so it distributes to each term, and terms are separated through addition and subtraction. So 1/2 of 2 is 1, so that'll just be natural log of x. And then 1/2 of 3 is just 3/2, and then natural log of y. And then that's all I can do, so that would be my answer. Okay, so again, we have to be able to work both ways. So this was expanding, so I assigned every term or every value a log, and then simplified wherever I could. So now I'm going to be asked to go the opposite direction. So given something like that, could I turn it into one natural log? So then now I have to do the reverse. So what I need to do is, same idea. So I'm going to zoom in just a little bit. I'm going to put everything together. So when I look at this, I'm going to look for coefficients and move my coefficients up first. So I have an implied 1 here, don't need to do anything with. The 2 I'm going to pull up, and then the 1/2 I'm going to pull up. So that's still log x, but instead of just 2 log y, that will turn into log of y to the power of 2, or log y squared. And then plus log of z plus 1. And then again, remember that if we have a 1/2, that's a square root. So I'm not going to make it to a 1/2 power, I'm going to make it a square root. So 1/2, remember, is a square root. So 1/3 would be a cube root, and so on. So instead of having this be to the 1/2 power, I'm going to rewrite it as the square root of z plus 1. Okay. So far so good? Okay, so now I'm going to go ahead and combine each of these. I'm just going to do one at a time here. So I'm going to combine these two together first. So instead of having 2 logs, I'm going to combine it and just have it as 1. I'm not really factoring it out. It kind of looks like I am, but I'm not really factoring it out. But I'm going to take these two and combine them, and then because I'm subtracting, that means I'm dividing. Subtraction and division go together, addition and multiplication. So I'm going to do x divided by y squared. So this is my numerator, the left one. First one goes in the numerator, and the second one in the denominator. Okay, so that's all I've done so far. So I'm going to do just one at a time. and then log square root of z plus 1. So I combined the first two together, subtraction turned into division. So now I still have log, so I'm trying to get it down to where it just has one log, and so I just have one more step to do. So I have log, because I have two, so I'm put those together, and I'm adding, and addition turns into multiplying. So I'll have x y squared, and then times z plus 1. So 1 log all my terms together. Okay? All right, backside. Okay, so this is where it gets a little bit weird here. So they want me to rewrite the expression in terms of 4s and 5s, basically, is what they're asking me to do. And so I have to think of, okay, how can I break 100 down to where it's in 4s and 5s? And so however you want to do that. So for 100, I know that's the same as 10 times 10. So I'm going to kind of go the long way here just because that way we can kind of see everything that we're thinking about. And I know 10 is 2 times 5. So 100 factors down to something like that. But again, I need to be in just 4s and just 5s. And so when I do this, I mean as a product, I can use exponents, you know, that sort of thing. But I don't want to do additions. Like I'm not trying to do like 5 plus 5 plus 5. I'm trying to do product, quotients, and powers. And the reason I'm trying to do that is because in my properties of logs, everything is either a product, a quotient, or a power. There's no sum property, there's no difference property. It's product, quotient, and power. So if I look at this, I know that the natural log of 100 is the same as 2 times 2 and 5 times 5. And so 2 times 2, so that would be 2 squared. And then 5 times 5 is 5 squared. So I broke it down to a product and as powers. So pretty close to what I want, but here it said to do 4s and 5s. So the 5 is good, but the 2 squared is not, other than the fact that, oh, hey, looky there, it's a 4. So 2 squared is 4, and then I have 5 squared. So now I've broken it down to bases of 4 and 5. And then just do, just like we did in example 3, now we just want to expand this. And so I'm going to assign a natural log to each of these values. So that would be the natural log of 4, and then the natural log of 5 squared. And then because it was multiplying, I'm going to switch that to addition. And I have one more step, right, because I still have a power here, so I can handle that by moving that to the front. And that's all they were asking us to do. Rewrite the 100 into values of 4 and 5 and expand it using our properties, and that's what we got. Okay, so again, just use products, quotients, and exponents. Okay, so moving on. Okay, so this is where we really have to like think about how do we simplify, like what does a log mean? So we have to remember what we're trying to always do here is we're always trying to find the exponent, right? So that's the part we really need to remember. You know, what's the exponent? Because that's what the logarithm is asking us, is what the heck is the exponent? And that sometimes gets people kind of confused because they don't understand what it is that you're trying to find. But a logarithm is always asking for what is our power. Sometimes we have to do a little bit of extra work to simplify things, but in general, we're just looking for a power. So if I look here, this is a base of e. And the first thing I always ask myself is, so let me write this a little bigger here. So I have log base e of 4e. Is there something I can put in that power to turn that into a 4e? Like e to the first, is that 4e? E squared, is that 4e? E to the fourth, is that 4e? So none of those things are 4e, so that means there's probably a property out there I could apply to make this work for me. And so one property is these are being multiplied together, so I can split them, right? I can give 4 its log and I can give e its log. So then that would be the natural log of 4, and then multiplying is addition, natural log of e. And so for here, the natural log of 4 certainly is nothing that I can think of. I could turn it into a decimal, but that's not what we're trying to do. And then, get rid of that now. Here I've got the natural log of e. So for the natural log of e, same thing. Now I know that natural log is the same as the log base of e. So what power would I put on this value here to turn it into e? For example, e to the 0 is 1. E to the first is, oh looky there, is e. So that means I could put a 1 here. E to the first is e. So what power on e turns it into e? 1. E to the first is e. And that's all I can do. Again, I'm not looking to make a decimal. Okay? All right. Let's take a look at the next one. So I have log base 4 of what power would give me 16. So again, I try to do a guess and check. 4 to the first is 4. That doesn't work. 4 to the second is 16. So what power do I need on 4 to be 16? I need a power of 2. Remember, we're always looking for the exponent. So what's my answer? My answer is 2. So what power do I need on 4 to get 16? I need a power of 2. Okay, moving on. Okay, so this one right here. So I have log base 2 of 1 over the square root of 2. So same thing again. What power do I need on 2 to get that? So I could try guess and check. 2 to the first is 2, 2 squared is 4, 2 to the 0 is 1. So nothing quickly, like some of you may be like thinking you know right away, which is great. So, but that's always what I kind of try to do, like a little guess and check first, and if nothing is clear, then I do a property. So I know that if I have the square root of 2, I can make that a 1/2 power, and I also know that if it's in the denominator, I can pull it up and make it negative. So that would be the same as log base 2, and then 2 to the negative 1/2. 1/2 because of the square root, negative because it's a fraction. So pretty much right here I'm done, because I know these are inverses, so that would actually cancel. And so then my answer would just be negative 1/2. Okay. Again, I could look right here and just say, okay, I know square root is a 1/2 power, and I know fractions come from negative exponents. So I could do that also. All right, so for D, so I'm not going to write this one out, but in terms of like I did up here, but I know 3 to the first is 3, guess and check. 3 squared is 9, 3 to the third is 27, so I missed my 18, so that means I can't figure that one out. 3 to the first is 3, 3 squared is 9, so no power gives me 18 or gives me 2, so I have to do a property. So if I'm subtracting, I can combine my logs. So I can make that log base 3. Subtraction is division, so 18 divided by 2. And then that's just 9. So then I have log base 3 of 9. And then I can do my guess and check here. So what power do I need on 3 to get a 9? So 3 to the first is 3. Nope. 3 to the second is 9. So I need a power of 2. So my answer is 2. Okay. So far so good? All right. Y'all could have said no at that point. I would have no idea. So I'm just going to assume so far so good. All right. So for this one here, so again, like this is a complicated looking piece, and so I'm certainly not going to do guess and check. 3 to the first is 3. It's certainly not going to give me that. So I'm going to go ahead and split this up because of the way they wrote it. It looks like they want me to split it. So I'm going to assign a log to each of these. And then separate through addition. And then I'm going to go ahead and work out what these numbers are. So that's 9 times 9 is 81. And then 2 to the 4th is 16. So now I can do my guess and check and see if I can come up with anything here. So here, so 3 to the first is 3, 3 squared is 9, 3 to the third is 27, 3 to the fourth is 81. So I know I needed a power of 4 to get the 81, so that's just 4. And then here, 3 to the first is 3, 3 squared is 9, 3 cubed is 27. So there's no power on this, so then I just leave it the way it is. And you can also tell, because 16 is a 2, right? Base of 2, and we're looking to get it to be a base of 3, and you can't turn a 2 into a 3. Okay? All right, and now F and G are kind of oddball ones. So if I look at this, what I'm looking at is this is a base of 8 and 32. And so I know 8 to the first is 8, and 8 squared is 64. And so there's no way I can make 8 into a 32, but I also know that 8 is base of 2. Like I can turn 8 into 2 times 2 times 2, and 32 is also just a bunch of 2's strung together. So because 8 and 32 all have that same base, meaning they're all generated from 2's, I should be able to convert this then somehow, some way. And so I'm going to show you 2 ways on this problem, which sometimes is good and sometimes is not. So first, if I look at, okay, well, 8 is 2 to the third. So I know that 8 is 2 to the power of 3. And then I know that 32 is 2 to the fifth. Okay, so if you're not sure how I did that, it's, you know, I have mad arithmetic skills. Okay, not really. Okay, so 8 is just 4 times 2, and then 4 breaks down. So 8 is 2 to the third, and then 32 is just, you know, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Okay, so I have like that part right there. And so then now what I'm trying to figure out is then now how do I, you know, somehow work these things out. And so if I look at this, I have a power of 5 here and a power of 3. And so if you think about this like just a little bit, is that a log is our exponents. So my exponents here are 5 and my exponents here are 3. And so if I look at that, I say, okay, I've got a power of 5 and a power of 3. So does that mean that my answer is 5/3, or is it possible that it could be 3/5? You know, like how would I figure out that part? Like, is it 5 over 3 or is it 3 to the 5th? And so just for the sake of trying to understand what we're doing here, is that we know that what's supposed to happen is that 8 to the 5/3 is supposed to be 32, or 8 to the 3/5 is supposed to be 32, right? Because isn't that what we're trying to figure out, is what number has to go here to make it be a 32? So if I look at just this part right here, a 1/3 means I'm doing a cube root. So that means I'm doing a cube root of 8, and I'm raising it to the power of 5. And the cube root of 8 is 2. And so then that would be 2, here, I'm writing super low, let me scoot that up. So the cube root of 8 is 2, and 2 to the 5th is 32. So that was the right one, so I'm going to cross this side off. Okay, so let's make sure, let me say this one more time. So I'm trying to figure out what power I need on 8 to be a 32. And I know that 8 is the same thing as 2 to the 3rd, and then 32 is the same as 2 to the 5th. So they have the same base, so there's something going on with these powers here. So if I look at that, I say, okay, I've got a 3 here and I've got a 5 here. So it's either going to be like 5/3 or 3/5. And we decided it wasn't this one, but I checked this one. So I was asking myself, if I take 8 and raise it to what I think is my answer, which is 5/3, I should get 32. So this is a 3rd power, so that means the cube root of 8 raised to the power of 5. And the cube root of 8 is 2, and to the 5th is 32. So then that means 5/3 is my right answer. Okay? Okay, so that's basically what we're doing. So another way to do this same kind of problem, so we're going to do the next one just slightly different just to see if this makes sense. So I'm going to do it both ways though, so we can kind of see that. So 125, I'm just going to break it down. That's 5 times 25, and 25 is 5 times 5. So then I know that I have 3 5s to make up 125. So this needs 3 5s, right? 1, 2, 3. That one needs 3 5s. And then 25 is just 5 times 5. So how many 5s does 25 need? It needs 2 of them. So I need 2 5s to make up 25. So 2 5s to make up 25. And I need 1, 2, 3, and I need 3 5s to make up 125. So that's another way to think about that as well. Okay, so it's the same idea, but just to make sure we understand. So 125 is 5 cubed, and 25 is 5 squared. And so then it's just 2 over 3. Okay? All right, so that was probably one of the confusing pieces. And now to do the very last one. So try to make this one super simple. So remember, we can't have negatives here or here. So then that means there is no solution to that, right? We're out of the domain of logs. And that, my folks, is it. All right, you guys finish up your worksheet. You should have a little over an hour, which is way more than enough time to do that. And have a good weekend.